central role in science and is often intertwined with other branches of science. Principles of chemistry are applicable in diverse areas such as weather patterns, functioning of brain, and operation of a computer. Production in chemical industries, manufacturing fertilizers, alkalis, acids, salt, dyes, polymers, drugs, soap, detergent, metals, alloys, etc., including new material. Chemistry contributes in a big way to the national economy. It plays an important role in meeting human needs for food, healthcare product, and other material aimed at improving the quality of life. This is exemplified by the large-scale production of a variety of fertilizers, improved variety of pesticides and insecticides. Chemistry provides method for the isolation of life-saving drugs from natural source and makes possible synthesis of such drugs. Some of these drugs are cisplatin and Taxol, which are effective in cancer therapy. The drug AZT, azithromycin, is used for helping its patient. Chemistry contributes to a large extent in the development and growth of a nation. With a better understanding of chemical principle, it has now become possible to design and synthesize new material having specific magnetic, electric and optical properties. This has led to the production of superconducting ceramics, conducting polymers, optical fibers, etc. Chemistry has helped in establishing industries which manufacture utility goods like acids, alkalis, dyes, polymers, metals, etc. These industries contribute in a big way to the economy of a nation and generate employment. In recent years, chemistry has helped in dealing with some of the pressing aspects of environmental degradation with a fair degree of success. Safer alternatives to the environmentally hazardous refrigerants like CFCs, chlorofluorocarbons, responsible for ozone depletion in the stratosphere, have been successfully synthesized. However, many big environmental problems continue to be matters of grave concern to the chemist. One such problem is the management of the greenhouse gases like methane, carbon dioxide, etc. Understanding of biochemical processes, use of enzymes for large scale production of chemicals, and synthesis of new exotic material are some of the intellectual challenges for the future generation of chemists. A developing country like India needs talented and creative chemists for accepting such challenges. To be a good chemist and to accept such challenges, one needs to understand the basic concept of chemistry, which begin with the concept of matter. Let us start with the nature of matter. 1.2 Nature of matter. You are already familiar with the term matter from your earlier classes. Anything which has mass and occupies space is called matter. Everything around us, for example, book, pen, pencil, water, air, all living beings, etc., are composed of matter. You know that they have mass and they occupy space. Let us recall the characteristics of states of matter, which you learned in your previous classes. 1.2.1 States of matter. You are aware that matter can exist in three physical states with a solid, liquid, and gas. The constituent particles of matter in these three states can be represented as shown in figure 1.1. Particles are Particles are held very close to each other in solids in an orderly fashion, and there is not much freedom of movement. In liquids, the particles are close to each other but they can move around. However, in gases, the particles are far apart as compared to those present in solid or liquid states, and their movement is easy and fast. Because of the such arrangement of particles, different states of matter exhibit the following characteristic. First, solid have definite volume and definite shape. Second, liquids have definite volume but do not have indefinite shape. They take the shape of the container in which they are placed. Third, gases have neither definite volume nor definite shape. They completely occupy the space in the container in which they are placed. These three states of matter are interconvertible by changing the condition of temperature and pressure. सॉलिड सॉलिड को हीट किए तो लिक्विड लिक्विड को हीट किए तो गैस गैस को कूल किए तो लिक्विड एंड लिक्विड को कूल किए देन फिर से सॉलिड on heating a solid usually changes to a liquid and the liquid on further heating changes to gas or vapor in the reverse process a gas on cooling liquefies to the liquid and the liquid on further cooling freezes to the solid 1.2.2 classification of matter in class ninth, chapter 2, you have learned that at the macroscopic or bulk level, matter can be classified as mixture or pure substance. These can be further subdivided as shown in figure 1.2. When all constituent particles of a substance are same in chemical nature, it is said to be a pure substance. A mixture contains many types of particles. A mixture contains particles of two or more pure substance which may be present in it in any ratio. Hence, their composition is variable. Pure substance forming mixture are called its components. Many of the substance present around you are mixtures. For example, sugar solution in water, air, tea, etc. are all mixtures. A mixtures may be homogeneous or heterogeneous. In a homogeneous mixture, the components completely mix with each other. This means particles of components of the mixtures are uniformly distributed throughout the bulk of the mixture and its composition is uniform throughout. Sugar solution and air are the example of homogeneous mixtures. In contrast to this, in a heterogeneous mixture, the composition is not uniform throughout and sometimes different components are visible. For example, mixtures of salt and sugar, grains and pulses, along with some dirt of and stone pieces, are heterogeneous mixtures. You can think of many more examples of mixtures which you come across in the daily life. It is worthwhile to mention here that the components of a mixture can be separated by using physical methods such as simple hand picking, filtration, crystallization, distillation, etc. Pure substance have characteristic different from mixtures. Constituent particles of pure substance have fixed composition. Copper, silver, gold, water, and glucose are some example of pure substance. Glucose contains carbon, hydrogen, and oxygen in a fixed ratio, and its particles are of same composition. Hence, like all other pure substance, glucose has a fixed composition. Also, its constituent, carbon, hydrogen, and oxygen, cannot be separated by simple physical methods. Pure substance can further be classified into elements and compounds. Particles of an element consist of only one type of atoms. These particles may exist as atoms or molecules. You may be familiar with atoms and molecules from the previous classes. However, you will be studying about them in detail in Unit 2. Sodium, copper, silver, hydrogen, oxygen, etc. are some example of elements. Their all atoms are of one type. However, the atoms of different elements are different in nature. Some elements, such as sodium or copper, contain atoms as their constituent particles, whereas in some others, the constituent particles are molecules which are formed by two or more atoms. For example, hydrogen, nitrogen, and oxygen gases consist of molecules in which two atoms combine to give their respective molecules. This is illustrated in figure 1.3. When two or more atoms of different elements combine together in a definite ratio, the molecule of a compound is obtained. Moreover, the constituent of a compound cannot be separated into simpler substance by physical methods. They can be separated by chemical methods. Examples of some compounds are water, ammonia, carbon dioxide, sugar, etc. The molecules of water and carbon dioxide are represented in figure 1.4. Note that a water molecule comprises two hydrogen atoms and one oxygen atom. Similarly, a molecule of carbon dioxide contains two oxygen atoms combined with one carbon atom. Thus, the atoms of different elements are present in a compound in a fixed and definite ratio, and his ratio is characteristics of a particular compound. Also, the properties of a compound are different from those of its constituent elements. For example, hydrogen and oxygen are gases, whereas the compound formed by their combination, that is water, is a liquid. It is interesting to note that hydrogen burns with a pop sound and oxygen is a supporter of combustion, but water is used as a fire extinguisher. 1.3 Properties of matter and their measurement. 1.3.1 Physical and chemical properties. Every substance has unique or characteristic properties. These properties can be classified into two categories: physical properties such as color, order, melting point, boiling point, density, etc., and chemical properties like composition, combustibility, reactivity with acid and bases, etc. Physical properties can be measured or observed without changing the identity or composition of the substance. The measurement of or observation of chemical properties requires a chemical change to occur. Measurement of physical properties does not require occurrence of a chemical change. The example of chemical properties are characteristic reaction of different substance. These include acidity or basicity, combustibility, etc. Chemists describe, interpret, and predict the behavior of substance on the basis of knowledge of their physical and chemical properties, which are determined by careful measurement and experimentation. In the following section, we will learn about the measurement of physical properties. 1.3.2 Measurement of physical properties. Quantitative measurement of properties is required for scientific investigation. Many properties of matter, such as length, area, volume, etc., are quantitative in nature. Any quantitative observation or measurement is represented by a number followed by units in which it is measured. For example, length of a room can be represented as 6 meter. Here, 6 is the number and m denotes meter, the unit in which the length is measured. Earlier, two different systems of measurement, that is the English system and the metric system, were being used in different parts of the world. The metric system, which originated in France in late 18th century, was more convenient as it was based on the decimal system. Late need of a common standard system was felt by the scientific community. Such a system was established in 1960 and is discussed in detail below. Maintaining the national standards of measurement. The system of units, including unit definitions, keeps on changing with time. Whenever the accuracy of measurement of a particular unit was enhanced substantially by adopting new principles. Member nations of meter treaty signed in 1875 agreed to the change the formal definition of that unit. Each modern industrialized country, including India, has a National Metrology Institute (NMI), which maintains standards of measurements. This responsibility has been given to the National Physical Laboratory (NPL), New Delhi. This laboratory establishes experiments to realize the base units and derive units of measurement and maintains national standards of measurement. These standards are periodically intercompared with standards maintained at other national metrology institute in the world, as well as those established at the International Bureau of Standards in Paris. So 1.3.3 The International System of Units SI. तो इसको हम सेकेंड लाइव वीडियो में कवर करेंगे. थैंक यू. हरे कृष्ण.